All right, today we're going to dive into one of history's most important and maybe most overlooked inventions, the Newcomen steam engine. And I know, it looks, well, ancient, but believe me, this is the machine that really set our modern world in motion.
So here's what we're going to cover. First, we'll see why this thing is basically the granddaddy of all engines. Then we'll break down how it actually works. After that, we'll get into the cool science behind vacuums and condensation. And finally, we'll look at its absolutely world-changing legacy. Let's jump in. So, to kick things off, what are we even looking at here? It might look like just some old rusty pump, but it's so much more than that. You're looking at the starting point, the actual genesis of our entire modern technological world. Now, I know what you might be thinking. It kind of looks like an old oil derrick, right? That big walking beam going up and down. But nope, it's not. It's something way more fundamental. In fact, get this. This one machine is the direct ancestor of, well, almost everything. Airplanes, the power plants that light our homes, trains, cars, even the refrigerator in your kitchen. Seriously, they can all trace their family tree right back to this invention. And it was invented way, way back in 1712 by an English ironmonger named Thomas Newcomen. Now, he wasn't trying to change the world. He was just trying to solve a really practical, really annoying problem: how to get all the water out of the local coal mines, which were constantly flooding. Okay, so let's get into the nitty-gritty. How does this thing actually work? It might look slow and clunky, but its cycle, this slow, powerful, repetitive motion, was completely revolutionary. And the parts are surprisingly simple. You've basically got four main things: a boiler down below to create steam, a big cylinder with a piston inside, this massive overhead beam that acts just like a giant seesaw, and then on the other end, the actual water pump that goes down into the mine. So here's how that all comes together in a cycle. First, the heavy pump on one side of the seesaw pulls the piston up. As it rises, the cylinder fills with low-pressure steam from the boiler. Then, and here's the clever part, a valve opens and sprays cold water into that cylinder. That hot steam instantly condenses, creating a vacuum. And this is the magic moment. The air pressure from our atmosphere, the air all around us, powerfully shoves the piston down into that vacuum. That's the power stroke. That's what pulls the pump up, lifting gallons of water out of the mine. Finally, the vacuum is broken, steam rushes back in, and the whole cycle starts over again, about 12 times a minute. Okay, so we've got the mechanics down, but now we have to talk about the science, about that invisible force that made this whole revolution possible in the first place. But wait, hold on a sec. Before we move on, let's just pause that cycle. We need to look much, much closer at what's happening inside that cylinder. How does this actually create enough force to move that massive beam? And this is the core principle. Just think about it. Outside, on top of the piston, you have the entire weight of Earth's atmosphere, trillions upon trillions of air molecules pushing down with incredible force. But inside the cylinder, right after that spray of cold water, almost all the steam molecules have vanished. They've turned back into a few drops of liquid. There's almost nothing left inside to push back up. It's this huge, massive imbalance of pressure that slams the piston down. And that is exactly why we call this an atmospheric engine. The power isn't coming from high-pressure steam pushing the piston up. Nope. It's coming from regular old atmospheric pressure pushing the piston down into a vacuum. And this was also way safer. See, back in the early 1700s, trying to build something that could safely contain high-pressure steam was almost impossible. Explosions were a huge, deadly risk. Newcomen's design just cleverly sidestepped that problem entirely. All right, now for the real aha moment. Let's talk about the power of condensation, because the math behind turning steam back into water is truly mind-boggling, and it's the real secret to this engine's power. So let me ask you a question. If you take 1 liter of water, about the size of a milk carton, and you boil it all into steam, how much space do you think that steam fills? 10 liters? Maybe 100? What's your guess? The answer is nearly 1,700 liters. That is a staggering, incredible amount of expansion. 1 liter of water becomes enough steam to fill 4 big kitchen refrigerators. It's huge. Okay, so now just reverse that process. That's what the Newcomen engine does. It takes a huge cylinder packed with steam, that massive 1,700 times volume, and with just a quick spray of cold water, it instantly collapses it all back down to a tiny little puddle of water. You can see how that creates such a powerful vacuum, almost in the blink of an eye. So, Let's zoom out now. Let's connect all this incredible science back to its massive historical impact. Because this wasn't just a clever pump. This was the starting gun for the entire Industrial Revolution. And here's the thing that really made Newcomen a genius. He didn't invent brand new components. I mean, people had known about fire and boiling water for ages. They knew about pistons and cylinders and even the basic concept of a vacuum. His true groundbreaking innovation was figuring out how to combine all these existing ideas into a single working cyclical engine that could do continuous, useful work. And you can literally see the direct line from his engine to today. It starts here in 1712 with the Newcomen engine. About 60 years later, James Watt comes along and dramatically improves it. That leads to the high-pressure steam engines that powered locomotives in the 1800s. And that, eventually, leads to the internal combustion engine in most of our cars today. But none of it happens without this crucial first step. And that really just leaves us with a powerful final thought. The Newcomen engine is perfect proof that sometimes the greatest innovations don't come from a single brand new discovery. They come from seeing how all the old pieces can fit together in a totally new way. And that simple act of combination, well, it can change the world forever.